Our next speaker is Yara Green, and she has a background in physics, more specifically in astrophysics. She's at the United States Patent Office, Patent and Trademark, for over 4 years as a patent examiner. She examines detectors of all wavelengths of light. And she's a second-year evening law student, which means you're going to be a patent attorney. Yes. At Catholic U, with a focus on intellectual property. I'm sorry. A volunteer in physics science fair judge every year, and this year. Organized a team of volunteers from the Patent Office to work with the entire third grade at Whittier Education Campus. And she's going to work with the fourth grade class in the spring term. Thank you. We come up here.
Okay, so I'm at the Patent Office. I've got a few of our volunteers here today. I think that our approach is a little bit different. I have about 9 to 11 volunteers, and the way that we needed to work in groups is that our schedule, while we are government employees, we are flexible, it's still, there's a lot of constraints on our time. So if we have a large group of people, we can pull from different people and have a consistent showing in 3 classrooms, 5 times a semester, plus the field trip. So we just finished with we're about to finish with our 3rd grade class. We're doing our field trip is at the Patent Office because we have the National Inventors Hall of Fame. So we are working with public affairs. We should have a tour with them, and hopefully, because all the science that we're doing, we're tying back to inventions and patents. And so when we talked with the principal, since we have enough volunteers, we did all the 3rd grade class, which is about 20 students per class, 3 classes. And then in the spring semester, we're going to do the entire 4th grade class, which I think is about the same size. And if we can keep a standing presence, then we have a fresh bunch of kids every 3rd grade, for the 3rd graders. And then the following year, these 3rd graders will get used to seeing us, and we'll see them again in 4th grade. So they'll have sort of back-to-back years of having scientists in their lives. Okay, so when we were developing our experiments, Whittier is a STEM school, which I found was an immense help since they're very science-oriented, and they're sort of inserting science in every aspect of their curriculum. So my co-chair, Christiane, and I, we met with the principal and their STEM coordinator, and after looking at the curriculum that they supplied us, since we're working with 3rd graders, we looked at their first semester science curricula and math curricula, and our group of volunteers brainstormed and came up with 5 experiments, and we gave it to the principal and the STEM coordinator, and like, tell us what you like, what you don't like. They liked everything, so that was to our advantage. And so we did that so they knew exactly what we're doing, and we settled on dates. We did a regular 3rd Thursday of a month, so it was very, everyone knew when we were coming. And then we're going to do that again, actually, next week with the principal for the 4th graders for next semester. Since we are kind of a large group and we are the Patent Office, we have a very diverse group of scientists and engineers. We have computer scientists, physics, biophysics, mechanical engineers. So we're able to kind of pull from different backgrounds for different experiments. And so that's kind of what we're using is we're sort of trying to capitalize on that. So while some other scientists are working outside their field, you have someone who knows what they're doing and they can sort of explain it to you. We tried everything back to patents since we are the Patent Office, and that's actually easier than we expected because when we were doing a gravity experiment to teach about gravity, we had one of those little army men with a parachute. So the patent that we could tie it back to were just parachutes. Or even for our dry ice cream experiment, there are patents on ice cream cones. I mean, there are patents for everything. There's everything around it, right? And then we also tried to adjust the experiment to the 3rd grade level. And a kind of a way to do that is to sort of remove variables that will sort of skew the results the wrong way. because we don't want to discourage them. And we know that a 0 result is still an answer, and it's still an important answer. But an 8-year-old, not so much. I mean, when I was doing experiments as a kid, I don't know how I turned out as a scientist because all my experiments went wrong consistently. So, kind of want to remove that because you have to have some kind of perseverance to look past, oh, this didn't work out, this didn't work out. So we try to minimize the variables, and so that way they can sort of focus on, all right, there's one main result that they should be aiming for. All our experiments were all hands-on. We did look to make sure that every kid had a role because they do start sort of grasping for things. The format of our experiments where we did like an opening where, we first reminded them that we're examiners, that we work in patents and we're inventions. Then we sort of did kind of an intro to the experiment. Then we broke out we divided the class into the groups, so each volunteer had 5 or 6 kids. You work on the experiment, and then we do a closing. And so that's where we sort of did a recap and then showed them the patents that sort of went along with the experiment. We did a couple, I feel like we tried to do some experiments that were more science intensive, and then some that were a little bit more dazzling, like solar car races, still very good science teaching about solar energy, and but at the same time it is pretty fun, and it's really exciting for the kids. Dry ice experiment, dry ice is really exciting. They're not fully grasping, what's happening with the dry ice and how it's turning into gas, but they did get to smash a frozen flower, they did get to eat ice cream, and so it's sort of just making it fun where they don't quite remember that there's like some serious intense science going on. And we did try to incorporate scientific terms that sounded cool but were kind of nonchalant about it, like, what are your data points, and when they're starting to say, oh, I have data, and so to kind of remind them that you are still doing science, what was your hypothesis, and these sound like kind of cool technical terms that they seem excited to use because it's not their standard vocabulary. So once we came up with our experiments, there weren't that many adjustments we had to make throughout the semester, partially because we were proactive at the beginning. Since we are a group of people, we did dry runs for our experiments the week before we went to the classroom. And there's 2 benefits to that. One is it gets out all the kinks and hiccups, and we try to find all the problems that might trip up the 3rd graders. And when you have 8 minds working on it, you start to come up with a lot. And people have kids, and we have a former 3rd grade teacher, so we're really drawing from everyone's minds, which I think is really helpful. The second is it gets the volunteers comfortable with the experiment. And I think once you can get the volunteers comfortable, then they're relaxed in the classroom, they can think on their feet if something were to go awry, and if the volunteers are comfortable, the kids are comfortable.
Yeah.
So, and then after we did an experiment, usually we talk amongst ourselves, what can we fix for next year, because I think as you all realize, you can improve every year because there's always something that didn't quite work out. And we also tried, so at least the classroom I was in, the teacher had everything written on the whiteboard like that they were working on, so we could kind of see what terms they were using, vocabulary words, and so we noticed at one point they were working on rounding in math, so we took that and applied it to the next experiment. Actually, it was our gravity experiment, where they were rounding, I think it was our gravity. It was estimation. Okay, so we took it where they had to measure candy, because candy math is always fun. So we took that and taught them how to round. They could apply rounding to weighing a piece of candy. So we tried to sort of pick up on what they were doing and sort of just kind of insert that into our experiment too. The only logistic adjustment, the biggest logistic adjustment we had to do was, at first, Christiane and I were bearing all the burden of the work, and while we loved it, we also have a job, so it was kind of hard to do the both. So we actually divided, each experiment went to a different volunteer to set up. I mean, we'd already picked out what the experiment was, but they had to make, tell us what are the supplies you need, come up with the exact experiment